And then in this particular investigation, we have these series of squares, and we know that it's going to have this kind of transformation, ax plus b, where A is a 2 by 2 matrix, B is a 2 by 1 column vector. And so we know that every point in a square and the image of it, such that this is our square. Okay, and so it always means it refers to the previous scenario. X minus 1, n minus 1, and n, this is before the n term. And so it's going to be in this particular form here. And the investigation actually say by considering these 3 points. Okay, so it gives you a direction where to go. So using those points and this scenario here, I want to see where in the world does 0, 0 go? Well, it goes to here. So using that idea there, I can start off by saying that 8, 0 is the image, is A times 0, 0 plus B. All right, and so when I do this, I know that anything, this is 0, anything times 0, that goes away, and so the matrix B is 8, 0. It is our column matrix, which talks about our column matrix. Using the next point, I go across 0, and I go up 8. This one here goes to 8, 4. So 8, 4 is my image, is going to be my A, which times 0, 8. 0, 8 goes to 8, 4, plus my B matrix, which is 8, 0. And so now, if I subtract this one over, it's 8, 4 minus 8, 0 is equal to A times 0, 8. And so I can say that 8 minus 8 is 0, so this is 0, 4 is equal to A times 0, 8. And I'm just going to hold on to this for a second. And then I'm going to use the final one where I know that this point 8, 0 ends up being 12, 0. So my image is 12, 0 is equal to some matrix A, which I know is a 2 by 2 matrix, times 8, 0 plus 8, 0 is what I then subtract this over, and I get 4, 0 is equal to A, 8, 0. And so if I take this and this, I know that 4, 0 and 0, 4 is going to equal to my A matrix times 8, 0 and 0, 8. Because the way I multiply this will produce that one when I multiply it by A. And similarly, this will be produced by A times 0, 8. And if I just look at it, I know that these values are just half the size. And so I'm going to end up with 4, 0, 0, 4, 0, and 0, 4 is going to be 1 half, 0, 0, 1 half, 0. Because if I check it, so if I multiply here, that gives me 4, 0. When I multiply here, that gives me these ones here. And so I do get my A matrix is an enlargement by a factor of half, which actually makes it smaller. Okay, and so we've used, in this investigation, we're able to calculate our A matrix and B matrix because we use these values. Okay, so now let's keep on going here. So it then says in number 2 to use the coordinates of the point of S1. So coordinate in point S1, here's S1, here's a nice point. We could use any point. We could use this one, this one, this one, this one, this, any point we want. That's a nice easy one, 10, 2. And that's going to go to this one here in the middle. Every point corresponds. So 10, 2 goes to 13, 1. And so we're going to test our matrix and see if it works. So if I take 10, 2 times my A matrix, then add the 8, 0, which is the B. So that's going to be when I multiply these two here, I end up with 5, 1 plus 8, 0 gives me 13, 1. And so now if I consider here, I have verified that a point in S1 goes to S2 is true based upon 1. Okay. Then it says determine the coordinates of 6, 6 in S3. Okay, so it wants us to check this in S3. So in order to do that in S3, we have to, let me start here. 6, 6 is here. And we want to know where it's going to end up in this third square here. So we're going to have to do this scenario 3 times. So if I go up here, this is number 3. I know if I go a half, 0, 0, a half, times 6, 6, plus 8, 0, this here will be for S1. And when I do that, I get 3, 3, plus 8, 0, which is 11, 3. And to get S2, I have to take 1 half, 0, 0, 1 half, times 11, 3, plus 8, 0, which here will become 11 over 2, 3 over 2, plus 8, 0, which is, that's 5.5, plus 8, 13.5. 13.5 and a 1.5. And then finally for S3, I do the same computation again. I go 13.5, 1.5 plus the 8, 0. And when I do that, now I'm going to cheat, look at my answers, but if you multiply, you get 14.75 and 0.75. And that is going to be an S3. This 0.66 will be an S3 in this particular position here. Okay, so continuing on now, it says apply the transformation to find x1, y1 in terms of x0, y0. And so now this is when it starts to really let me clean this up a little bit. It starts. Okay, so continuing on, now we're going to actually start to generalize this scenario. And so I know that x1, y1 is going to equal to a times x0, y0 plus 8, 0. When I do that, when I multiply these two matrices here, I get 1 half x0 plus 8, and then 1 half y0. And so this is going to be x1, y1. And then it says, let's find x2, y2. Well, x2, y2 is equal to 1 half, 0, 0, 1 half times x1, y1 plus 8, 0. But I know that this is x1, y1. So I'm going to replace that with half x0 plus 8 and a half y0. And now I'm going to multiply it out and simplify. And so when I do that, I multiply here and here. And so I get a quarter x0 plus 4 plus 8. And this one here ends up being a quarter y0. And this is x2, y2. Okay, and then it says, hence, show that x3, y3 is equal to this particular matrix here. And I can start to see, based upon my x2, y2, how it's starting to look. So now x3, y3 is equal to 1/2, 0, 0, 1/2, quarter plus x0 plus 4 plus 8, quarter y0, and plus an 8, 0 at the end. So when I multiply here, I get 1/8 x0 plus 2 plus 4 plus 8. And then my y is going to be 1/8 y0. So this is x cubed, y cubed. So now it says, using geometric series, find an expression for x and yn. So if I consider this, I know then that x and yn, if I consider this pattern here, right? Well, if I look at this first one here, this is 2 cubed. And so I can see that this is going to be 1 over 2 to the n y0. When I look at the x value, though, this one's a little bit more I can see that this one here is also 1x0. And then I got to add on, this here is a geometric sequence, and it goes 8 to 8 plus 4 plus 2, and so on and so forth. And so if we recognize that this is the sum of a geometric sequence is equal to u1, 1 minus r to the n over 1 minus r. This is from your formula booklet. So my u1 is 8. Here in this case, each time is times a half. 1 minus a half to the n over 1 minus a half equals, and I simplify this a little bit, I have 8, 1 minus 1 over 2 to the n over 1/2. If I flip, this is 16, 1 minus 1 over 2 to the n. And so if I add this on here, then I know that's 1/2 2 to the n x0 plus 16 times 1 minus 2 to the n. And so this here is a formula. This is my formula for x sub xn, yn. Okay, in the last part of the investigation, we want to find, use your conjecture to determine the coordinates of image 6, 5 and S4. So 6, 2 and S4. So we want to find 6, 2 in S4. Well, that means I'm going to go X4, Y4. And this is X0, Y0. It's the first point I'm looking at. So using my formula, it's 1/2 to the, let me try that. So if I just plug it in, I have 1, 4 plus 16, 1 minus over 2 to the 4. And this, I forgot my x0, and then this is to the 4th y0. And if I do that, this is 1 over 16 x0 plus 16 minus, if I distribute 16 minus 1. This is 16 as well. And this will be 1 over 16 y0. So this will be x to the 4th, y to the 4th. Now, but I recognize here is my x0, y0. And so I can go 1 over 16 times 6 plus 15. and I put the 2 in, I get 1 over 16 times 2. And when I do all this calculation, I end up with, and I'm just looking at my notes, I get 15.375, comma 0.125. This will be my point that I end up with. Okay. If there's any parts you want to talk about some more, let me know.